Welcome to today's Explainer. Look, if you've paid even a little bit of attention to the business world lately, you know we're absolutely swimming in AI hype, right? Everyone's talking about chatbots and algorithms. But today, we're going to cut right through that noise. We're looking at real, tangible, boots on the ground case studies from modern manufacturing. We're taking all those big abstract promises of generative AI and anchoring them in cold, hard factory floor reality. Which brings us to the ultimate question, the one sitting on every single business leader's mind right now. Sure, chatbots are fun to play with, but does this actually reduce operational risk? Does AI actually drive sustainable profitability on the factory floor? Well, today, we're going to prove its value with hard data. We aren't just going to tell you AI works, we're going to show you exactly how organizations of all sizes are leveraging it to totally redefine how they operate, innovate, and compete. Okay, let's dive into this. We're going to structure this explainer like a tour of a modern smart factory. First, we'll visit the R&D and design lab. Next, we'll head to the loading docks to look at optimizing the supply chain. Then onto the loud, busy production floor for predictive maintenance. And finally, we'll wrap things up at the quality control checkpoint. All right, let's transition right into our first stop, redesigning R&D with AI, looking specifically at General Motors. So for a massive automaker like GM, there is this constant pressing need for what they call lightweighting, basically reducing the weight of the vehicle to boost fuel efficiency and meet some pretty strict regulatory standards. And the shift in how they actually achieve that is brilliant. Traditional CAD design meant a ton of manual iteration. It was often plagued by material waste and clunky, heavy structures simply because it was limited by human constraints. But with generative AI, it's a whole new ballgame. Instead of manually testing every single idea, an engineer just inputs their performance criteria, and the AI instantly fires back dozens of highly optimized options. You get enhanced strength, incredible material efficiency, and, crucially, that much-needed weight reduction.
And you know, the data really speaks for itself here. By using generative AI to rethink just one component, we're talking about a simple seat bracket, GM was able to reduce the part's weight by a massive 26%. And they didn't just save weight, they actually reduced the cost of producing that part by 8%. Think about that scale for a second. When you multiply those percentages across the millions of parts an automaker churns out, you are looking at a literal revolutionary leap in competitiveness and efficiency.
But hey, a perfectly designed part means absolutely nothing if you don't have the materials to actually build it. Which brings us to stop number 2, optimizing the supply chain, featuring Shanghai Pepsi Cola. As a massive beverage manufacturer, they're dealing with a wildly variable demand cycle, fluctuating consumer tastes, and constant raw material constraints. Historically, trying to manage all that meant relying on static forecasting. And let's be honest, using the past to blindly predict a volatile future usually just gets you excess inventory or terrifying stockouts. It's a completely reactive posture. Shanghai Pepsi Cola realized they needed a dynamic, real-time AI optimization model. They needed a system that could juggle a dozen different constraints simultaneously and adjust operations on the fly. The sheer autonomy of this system is what makes it a real game changer. It plugs directly into the factory's electronic data interchange to communicate autonomously with suppliers. So if a supplier has a delay, the AI doesn't wait around for a human manager to notice the red flag. It independently adjusts reorder points, recommends alternative suppliers, or reroutes shipments in real time to prevent bottlenecks. It even lets managers run these continuous what-if scenario tests to see exactly how different inventory strategies will impact their bottom line. It is literally the ultimate proactive supply chain. Okay, moving on. Let's step away from the loading dock and onto the loud, busy production floor for stop number 3, predictive maintenance in auto and glass manufacturing. Now, what's really interesting here is the massive paradigm shift this represents. Maintenance is almost always seen as a necessary evil, right? A sunk cost. But when you manage it intelligently with AI, it actually becomes a massive competitive advantage. You can't fix what you can't measure. So Internet of Things, or IoT, sensors are deployed to actively listen to the heartbeat of the equipment. They're constantly collecting hypergranular data on vibrations, temperature, and output straight from the factory floor. Then, all of that sensor data is fed straight into predictive AI models. The AI instantly analyzes the data to sniff out hidden systemic anomalies, sometimes weeks before a catastrophic failure actually occurs. For example, in one automotive engine facility, the AI was able to detect insufficient lubrication in specific CNC machines, the computer-controlled machines shaping cylinder heads and crankshafts. By catching this super early, the maintenance team shifted completely from reacting to broken machines to proactively scheduling targeted, quick interventions.
And the return on investment for this US-based automotive manufacturer was completely transformative. They saw a 60% drop in unplanned downtime. To put that into perspective, that reduction translated into a monthly production increase equivalent to 200 extra engine units. On top of that, their maintenance costs dropped by 25%. Why? Because they weren't wasting time on unnecessary time-based checkups anymore. They literally only fixed what the AI told them was actually about to break.
And this predictive power goes way beyond just fixing machines. It optimizes energy too. Take a look at Saint-Gobain and BlueScope, who are leaders in glass and building materials. If you've ever stood anywhere near an industrial glass furnace, you know the sheer, staggering scale of energy it consumes. Well, they use agentic AI to centralize and automate real-time process adjustments across their facilities. The result? A 15% reduction in overall energy consumption. That is saving them millions of dollars annually. Plus, they saw a 20% improvement in furnace productivity. The AI helped them produce higher volumes without expanding their energy footprint, which perfectly aligns those sweet cost savings with their corporate sustainability goals.
All right, we've finally reached the last stop on our factory tour: flawless quality control in electronics manufacturing.
In the electronics world, printed circuit boards are becoming virtually microscopic, which makes human error a massive bottleneck that accidentally lets defective parts slip through to the customer. Now, traditional automated optical inspection, or AOI, relied on these very rigid rule-based algorithms. It had a lower detection rate, it constantly missed defects, and it generated an incredibly high rate of false positives. That forced human operators to waste precious time manually rechecking parts. Contrast that with AI-driven inspection. By utilizing deep learning models trained on thousands of images, the AI system achieves a dramatically higher detection rate with pinpoint accuracy. The AI visual inspection process is highly advanced, but it's actually surprisingly straightforward in its workflow. Step 1, a high-resolution camera captures an image of the printed circuit board. Step 2, the AI model analyzes that image using deep learning, specifically hunting for microscopic flaws that a human eye would easily miss. And Step 3, it immediately identifies and classifies those defects, making an instant decision to either accept or reject the board.
The operational results here are simply stunning. Within just 6 months of implementing this, the defect rate dropped significantly, saving massive amounts of money on rework and warranty claims. Inspection throughput more than doubled, and they did it without increasing labor costs. But here is the most fascinating part, a real aha moment for the team. The AI even found hidden correlations that humans never noticed. It actually discovered that minor fluctuations in the plant's ambient humidity were causing specific soldering defects. The factory adjusted their climate control based entirely on this AI insight, improving quality even further. How cool is that?
So bringing it all together, from reactive to proactive, the AI shift. Across every single department we toured today, from R&D designing lighter brackets, to the supply chain autonomously rerouting shipments, to sensors predicting a machine breakdown, all the way to cameras catching microscopic soldering flaws, the overarching theme is a monumental shift. Manufacturing is moving away from reactive, manual, rigid processes and fully embracing proactive, autonomous AI systems. So, I want to leave you with this lingering question to think about regarding your own operations. Are you still reacting to the factory floor, letting historical data and unexpected breakdowns dictate your schedule? Or are you leveraging the generative AI revolution to predict the future, drive sustainable profitability, and stay ahead of the competition? The data is crystal clear. The smartest factories are the ones that see the future before it happens. Thanks for joining me on this explainer, and keep innovating.